Dear students, now today we are going to discuss about interpolation. Interpolation is the process of finding the value of a function for any value of argument. Argument here, it means independent variable within an interval for which some values are given. So within an interval, this is altogether within an interval for which some values are given. Therefore, interpolation is the art of reading between the lines in a given table. Okay. Now, what is the meaning of extrapolation? Although extrapolation we have to know because we are going to study the interpolation. Extrapolation is the process of finding the value of a function or any value of argument, means independent variable outside an interval. Okay, this should be outside an interval, the given interval, and the outside is extrapolation, for which some values are given. Now we are going to discuss few interpolation processes for equally spaced data. Okay, so in that connection, the first method is known as Newton's forward difference formula. So what is the statement? Let us consider y is equal to fx is a function, and we may take the values, the different values, sub-interval you can say, the sub-interval x naught, x1. x1 means x1 stand for, I already said this is equally spaced. It means x1 stand for x naught plus h, while that x2 stand for x naught plus 2h. Okay, so the difference between both the interval is h. Already you know x naught is the initial value. The initial value is x naught. Now you can look x naught plus h, x naught plus 2h. Okay, up to xn of x. The process of finding the value of y corresponding to any value of x is equal to xi between x naught and xn is called interpolation. So this is the statement of interpolation, we can say. Now this is a very important table. You have to remember what is the forward, Newton's forward interpolation, how to calculate numerically. So here you know first the set of values of x and y will be given. So here the set of values you may assume x naught, x1, x2, x3, x4 and x5. It means there are 6 set of values. The corresponding value of y naught, y1, y2, y3, y4, y5. I have already said this means x1 means x naught plus h, x2 means x naught plus 2h, this x3 means x naught plus 3h, x4 means x naught plus 4h, and x5 means x naught plus 5h. Okay, so this is already with the help of x naught and space only you can get. The forward operator is denoted by del y. Look here, and the difference between these, look here, the difference between these is known as del y naught. And what is the value of del y naught? Del y naught is y1 minus y naught. Look here, y1 minus y naught, y1 minus y naught. Similarly, the difference between this is known as del y1, and del y1 means y2 minus y1. Okay. Similarly, del y2, y3 minus y2, del y3, y4 minus y3, del y4, y5 minus y4. Similarly, now here, the same thing will be here also in between this. In between this means del square. This is the del square y. The del square y means the difference is del square y naught. Del square y naught means del y1 minus del y naught. Okay. So similarly, we can write del square y1, del square y2, del square y3. Now again here, the higher order is del cube y. The del cube y is del cube y naught, and del cube y naught means del square y1 minus del square y naught. And similarly, we can write del cube y1, del cube y2. Now here, del 4 y naught. In the similar manner, the difference between this is del cube y1 minus del cube y naught, and del 4 y1 is del cube y2 minus del cube y1. And their difference is del power 5 y naught is equal to del power 4 y1 minus del power 4 y naught. Now you can stop here and you can look here the value last entry here x5. Okay, and here this is also del 5, and here del 5. So this is the symmetry between the forward table, and this look like triangle. Just you look, the base is triangle. Yes. Okay. So this is the vertex. Vertex is already here. Vertex is already here. So this is like a triangle, and vertex is already here, and this is known as Newton's forward interpolation formula. Newton forward interpolation formula. Okay, so in this way, you can develop, if the entries are given, then you can develop the Newton forward interpolation formula. Moving further, by using the result, you can develop this formula. This formula is Newton forward interpolation formula. And how? What is the formula? Formula you have to remember: y and x is equal to y naught plus p y naught p del y naught. Del y naught means this is forward del, the forward difference. The forward del y naught plus pp minus 1 by factorial 2 del square y naught plus pp minus 1 p minus 2 by factorial 3 del p y naught, and so on. Means nth term will be pp minus 1 p minus 2 up to p minus n plus 1 divided by factorial n del power n y naught. Here p is x minus x naught by h. Okay. Now for example, let us look at an example. You find the value of tan 0.12. Okay, so x and y, you have to prepare the table for given value of x. X is already given, that is 0.10. Just to check, this is already given. X is 0.10, 0.15, equally spaced. Okay, 0.15, 0.20, 0.25, and 0.30. The value of y are given. These are the values of y, and just check, you are required 0.12. It means this is in between this. So this is why this is forward, any starting of the table from the initial. So this is the value false here. So we have to apply the Newton's forward interpolation formula to know this missing result, you can say. So this is one of the best application of Newton forward. We may apply the Newton forward if the data are missing. Let us suppose some of in your laboratory you are doing some experiment, and in the meantime, and you are taking the data with respect to time, and you miss some data just because someone want to talk to you on the phone, and in the meanwhile you are having the every data, but you have missed some intermediate data. Then with the help of Newton forward formula, you will get it if you are having other data. This is the beautiful application of Newton's forward interpolation formula. So let us look how to solve. First, you plot all the values. So these are the set of values. The values है हमारी, and now y is also given. Then this is difference. दोनों का difference means 0.1511 minus 0.1003. You will get this. Then similarly, the difference between this, you will get this. The difference between this, you will get this. And the difference between this, you will get this. Now again, the similar manner. The difference is 0.0008. Then here the difference is this. Now here the difference is this. Now again, this difference is 0.0002 and 0.004. And ultimately, you will get this value. Now we will put these values in the table here in the formula, and we will get y and x is equal to tan this fx. You will get this. P is x minus x naught by h. You will calculate the value is p will be 0.4. After putting all the values, you are getting here 0 tan 0.12 is nothing but 0.1205. So this is the actual value. Now look the second problem. We find example, if fx is known at the following data points, then find f 0.5. You can check here 0, 1, 2, 3, 4 given set of values of x, and f is or fx is 17, 23, 55, and 109. Required is 0.5, just in between this, means forward formula we will use. So again you will plot 0, 1, 2, 3, 4. Here the values are given 17, 23, 55, 109. Now the difference is 6. Here the difference is 16. The difference is 32. Here the difference is 54. Now the difference is 10, 16, and 22. Now here the 6, 6, and here is 0. It means now we'll apply the value. After putting the value here in Newton forward interpolation formula, if x is equal to 0.5, p is 0.5, then put here and you will get the value f of 0.5, that is 3.125. This is the result by using Newton forward interpolation formula, the result of missing data. So in this way, by using the Newton forward interpolation formula, you got the value, missing value in the data. Thank you very much. Thank you. Thank you. Stay safe. Thank you.